All right, so what we're going to talk about working with Java applications and Neo4j, how to build applications, and we will be doing some live coding today. So my name's Jennifer Reif. My contact information there is in the lower left-hand corner. It'll also be on the final slide, so don't feel like you have to scribble that down really fast or take a quick shot. But I'll be around the conference all day today, tomorrow, and through the dev zone and vendor area and so on. So if you think of anything, feel free to just grab me in the hall when you see me or so on. But if you think of something after the conference ends, as that's usually when our best questions come to us, right? After we can't access people anymore, feel free to contact me digitally, however is most comfortable there. So a little bit of background on myself. I'm a developer and advocate at Neo4j. I've been here a little over 4 years now, and I like learning. Hopefully all of us do too, otherwise we probably wouldn't be here. But then I like taking what I've learned and sharing that with others around me. So whether that's through writing blog posts, technical blog posts, or speaking at conferences or meetups, or even virtual events, I'll take any of them. I enjoy all of them. So I do a variety of mediums on technical content there. There's a few other things I do like to do outside of work. However, most of those just boil down to the fact that I'm a geek and I kind of like it that way. So that's just kind of me in a nutshell. I like tech and other geeky things, if you cannot tell from my shirt today. Okay, so let's talk a little bit about developing applications then, what that looks like, especially when you're dealing with Java applications and databases. There's a few options you have out there today when you're dealing with different types of databases on how to build a Java connection to those. So when you're dealing with relational databases, you have things like a straight JDBC connection or even a JDBC template. There's things now like Juke, which kind of abstracts or tries to abstract some of that SQL stuff away from you so you don't have to mess with that. And then things like JPA or Hibernate, which help you map things between relational and Java. When you're dealing with NoSQL or document databases, those two terms are often used synonymously, you have things like MongoDB, and there's a variety of integrations you can use with MongoDB. One example of that is Spring Data MongoDB. They have a connector and a data project for that. And then when you're dealing with Graph, you have something like Neo4j, which again, Spring Data Neo4j is a Spring project that connects to Neo4j, but you have other integrations as well that you can use with Java applications. So as a Java developer, why would we want to choose something like Graph? What is that going to do for us? If we were to take an example Java domain, for instance, we have Java versions like the Java programming language, and we're going to take, say, Java 8, Java 11, Java 17, so on, and we want to figure out how that language has changed over time. So what are the diffs between the different versions of the language? What are the packages, modules, fields, methods, and so on maybe that have changed? So we can create kind of this graph, if you will. We have Java versions and the diffs between them. How would we create this in a Java application? Well, we'd probably start with a domain class, right? A Java entity. We have our class, which is kind of the highest level, which represents our entity or our object, typically represents the domain type. It's a general outline for your objects of that specific type. So for instance, we have a class of person. That's typically your outline for that domain object of person, right? So if we have that for Java versions, in this case, there's a little bit of sample code on the right-hand side there. We have our class Java version, and this is represents that domain type. Then we might want to add some variables or properties, which are details for that entity. It's like metadata. Values may not always exist there, so you may have, for instance, codename is one example here. Codename existed on Java versions, I think for 6 or maybe 7, Java version 7 and before. However, starting at Java version 8, that kind of went away, and you don't see codenames now on Java versions. So sometimes that field will be blank or null, sometimes it's there, depending on what Java version you're pulling. Then you might have something like a constructor, which is going to be an instance of an object. So each instance is going to be unique, a unique object with a variety of different info. Like I said, code names sometimes may appear for certain instances or not, depending on what version you're dealing with. So if you've done a whole lot with Graph, if you've been around Graph a whole lot, this looks very similar, right? This looks kind of like node, label, property, all this kind of stuff is this object entity sort of thing, right? Then if we want to add relationships in our Java domain, we can add a variable as a pointer to another object, right? So whether you're dealing with, connecting to MongoDB or relational database tables or Neo4j graph, all of this, you're going to use a similar construct here. You're going to create a variable that's going to point to another object type. This links your entities together, and sometimes you'll have annotations to help map across. For instance, if you're using something like Spring Data MongoDB, there's a connector, an annotation you use there. For something like Spring Data JPA, you'll use an at one-to-many or many-to-one annotation to help you map that relationship to another entity type. And again, no matter what data domain you're dealing with and what database type you have, this looks relatively similar across the board. So when you're dealing with relational databases versus graph databases, you have set theory on the relational database side, you have graph theory or entity network on the graph database side. Your schema is going to be rigid and enforced on the relational database side. Your schema is going to be flexible and optional on the graph database side. That means a little bit less mapping and schema enforcement on the application side as well. Entities, you're dealing with table rows. Entities on the graphs, you're dealing with nodes or objects. Metadata are going to be columns on the relational side. Metadata are going to be your properties, your node and relationship properties on the graph. Relationships, you're going to craft those joins when you write your SQL queries, right? You're going to figure out how to map those tables together. On the relational side, where relationships are actually stored in the graph database together with the entities themselves. Queries are your joins at runtime, so again, you're crafting those and running those at read. Queries on the graph, you're doing those joins at write, so then your reads are going to be less cumbersome. Indexes or lookup scans on the relational side. Indexes are a place to start in the graph for traversal on the graph side. So you can see how different these two are. And when you're looking at a Java domain, a Java application, the graph database side actually maps much more closely to that object-oriented language type of structure. And this is why when you're dealing with object-oriented programming languages, maybe specifically Java, the graph database is going to map much more closely to that. Where when you're dealing with relational databases, you're ending up having to translate or kind of map yourself how that kind of object-oriented language is going to map to a column, row, table type of structure on the back end. So there's a little bit more work, a little bit more logic and kind of thinking involved there to make the two meet in the middle, if you will. Okay, so let's talk a little bit about the graph data model. If you're familiar with graphs, this already looks very, very familiar to you. But property graph deals with nodes and relationships, or vertexes and edges, if you're more on the mathematical terminology. Nodes are going to represent your objects or your entities, and you can label them, so kind of group them or categorize them. Now again, this looks pretty similar to the way we have Java class names, right? And you can also have properties associated with the nodes. So these are, again, are your metadata. They're your details that make the object unique. For instance, we have a Java version 17, and we have a specific date that it went GA. Down here, we have a Java version 6. The GA date, we also have a code name that goes along with that. Then you can see our version diff. We have a from version and to version field specified there. Relationships, you have to have a type, so you have to, again, give it context for what type of relationship exists between the entities, and you have to have a direction as well. And then you can also have properties associated with relationships. So for instance, we have our two Java versions. We could directly relate those and say we can migrate from one Java version to the next using a three-step migration process. Now again, those 3 steps would be very high-level general steps going from 6 to 17, right? There would be a lot more details involved there. But nodes can also share multiple relationships. So you could have different types of context there, just depending on the data model and what needs you had for your data domain. Label is kind of like a group of nodes, like a category. It's kind of like your domain class, as I mentioned in Java. Then we can also have kind of subgroupings. So within the general label of person, we could have sublabels of employee and customer. And notice that there's kind of one entity in the middle that actually shares all 3 labels. This also looks very, very familiar to Java developers, as this is kind of that sub-hierarchy class structure that you get, the nested classes or hierarchy classes. Properties are key value pairs. They're associated with either nodes or relationships, and it's kind of like a variable name and value is the way I like to think of it. So you have the string, variable name equals variable value. Properties are going to work very, very similarly on Neo4j. All right, a little bit of modeling. Neo4j is known for being whiteboard friendly. Mostly that just means that when you sit down with a new domain or when you're having to kind of model or work with a domain, you typically might go to the whiteboard first. Right? You'll pick up a marker or pen and paper, and you'll sit down and draw out how is my data connected, how does the process flow, etc. So for instance, this is the actual full model of the data we're going to be dealing with today, but we're going to focus in on just kind of this left-hand side. So we've got Java versions and diffs, and then kind of the sub-deltas that go within those diffs. So the changes to the modular package and classes and fields and so on. So we draw this model out, and that looks pretty good to us. But then when we put it into the database, this is kind of the organization of the way the data is stored. So you notice the data looks in the database exactly as it does when we drew it on the whiteboard, exactly as it does in the real world. So that mapping, again, one-to-one, you're not having to do a lot of translation or kind of filling in the blanks for people. It's very easy to understand the data model and what's actually in the database. All right, let's dive into demo stuff. I'm going to talk a little bit about kind of the layers that I have here, and then we'll jump into code and build something. So I am starting with Neo4j Aura DB. I have a free tier instance out there. Anyone is welcome to grab a free tier instance. There'll be a link on the last slide. You just have to fill out a quick form and spin up a free instance there. And I have Java language version data loaded. Now I have links out on my GitHub repositories for how I loaded that data, where the data is coming from, and so on. But this is the data that we have in our system for now. So we have Java versions and we have version diffs. And we're going to look at the diffs between Java versions, right? Makes sense. We have some different language drivers that we could pick. I'm obviously going to be using Java today, but there are lots of other options too. We have several official drivers that we provide out of the box at Neo4j, and there's several other provided by community and partner support as well. So feel free to just query your language of choice with Neo4j at Google on the Google search engine, and you'll probably come across something that's provided there. I'm also going to be using Spring Data Neo4j, which uses the Java driver inside of that. But there are other framework options too. You could use things like Quarkus, Helidon, Micronaut, and there's documentation, examples, blog posts, and so on about those sorts of frameworks out there too. My basis of knowledge, I just have some background in Spring, and so that's kind of my most comfort go-to, if you will. Spring is going to provide me the Spring initializer, which is going to help me kind of put a skeleton project together right out of the box. It's also going to reduce some boilerplate using Spring Boot, which helps me, of course, in my demo stuff for today, so I can condense the time just a little bit, which is nice. There's annotation-based object graph mapper for your plain old Java objects. So if you're used to ORMs or object relational mappers, then this is basically the graph rendition of that. You also get query derivation and domain-specific language for custom queries, which this basically means that Spring is going to provide a few implementations of kind of common methods right out of the box, and then you can write your own custom ones using the domain-specific language for that database. In our instance, it's going to be Cypher, because we're dealing with Neo4j. And then Spring Data also has really easy connection to Neo4j. Spring Data Neo4j uses the Bolt protocol by nature. That's what we're going to default to. But you also do have the option to connect using HTTP. Okay, let's dive into code now. So we'll jump over to our browser window here and zoom way in so everybody can see all right. And we're going to stick with Maven and Java, of course, for today. And 2.7 is kind of the standard right now, standard version of Spring Boot. I'm going to kind of organize this for my own personal projects into kind of my folder, my own grouping. And we're going to call this Coffee Matrix Demo. I'll leave that all the same. We're going to use the jar, and we can use Java 17. That's no problem. And then we can start adding our dependencies. The first thing we want is Spring Web, which is going to provide our capability to create a REST API, which is what we're going to do in order to retrieve some of the data and show that. I also want to use Lombok. Now, some people love Lombok, some people hate it, but it's really nice for demo purposes because it's going to cut down again on some of that boilerplate, which I'll talk about as we go through. Then we also want the dependency for Neo4j as well. So now we have our 3 dependencies, which isn't too bad. We're going to go ahead and generate this project, and it'll dump it into my downloads folder. And I'll unzip that and open that in IntelliJ. And I almost forgot to. I'm going to increase my font size and make this a little bit more readable too while I'm at it. And, oops. Okay, all right. Dive into this. So the first thing I like to do is I like to open my palm. Is that readable, everybody in the back? Okay. Great. Okay, so I always like to check my palm just to make sure everything's there and everything looks good and we're not missing anything. So we have Java version, we have our Spring Data Neo4j dependency in here, we have our web dependency to create our REST API, and we have Lombok, which is going to help us with some boilerplate. We also have a test dependency and the Maven plugin, which is cool. That's pretty much all Spring is going to provide for us, but it also does create the main method here for us, just the initial one. Now, if I go into resources, I do have some environment variables set in my local machine for now. And so what I'm going to do is, in order to connect to Neo4j database, you have to have those database credentials, right, to connect. And so I'm going to sync that up, but I'm just going to use the embedded environment variables that I've set. And the username. I never want to type, because you have to let go of the shift key when you type the 4, and then you have to add the shift key back to get the rest of it, so I always mess that up somehow. Password, and the database. So Neo4j does support multi-database, as many vendors, database vendors do now, and so I have to specify a particular database. Okay. So I'm going to put everything today inside the main application class, or kind of outside, but in that file still. However, if you go out to my repo, the code looks much cleaner, and it's all in separate files. It looks nice. So we're just going to keep it kind of close and easy for today. So the first off, we want to create our domain class, which is Java version. So we're going to start with Java versions. We want to specify this as a node in our database. And then we also need to add a couple of annotations to this. So I want Lombok to create, my getters, setters equals hash code and toString methods for me, so that I don't have to write all that boilerplate myself, for now at least. And then I want Lombok to create a required argument constructor for me. So it'll take care of the constructor building for me as well. Now we can dive in and start filling in on our properties here, or our variables, if you will. We have an ID, and this is going to be private string, and we're going to use the Java version. Now, I actually, because version is a keyword in Java, I actually named this differently in the database than what I wanted to name it on the application side. So I need to map that by specifying an app property annotation. So it's going to map the Java version on the application to the version property on the database. Now, we'll fill in a couple other fields that we want. So for instance, we want the name, which isn't too different from the version number. And then we can have the code name, if it has one, of course, the status, so whether it's end of life or long-term support or so on. And then there's also a link for the API spec too for each version out there. The last thing we want to take on is kind of one of my favorites, and we want to pull in the date that it went GA, so live or public availability, and then we want the end of life date for the version as well. This I kind of find fun when you're dealing with language versions. Okay, now we'll need to do a couple more things. So we have our domain object defined, but we need to define our repository that's going to give us a kind of methods to access the database, and then we need to define our controller, which is going to let us call those defined methods, basically implement them with a REST API. So let's first start with our repository. We're going to call this Java version repository, and it's going to extend the Neo4j repository. which Neo4j is an extension of CRUD repository. So you can use the general CRUD repository by all means, but Neo4j repository is going to give you just a couple extra niceties, which most of the time I don't specifically use. But there are a few things that are added specific to Neo4j. The first thing we need here is we need to specify the object type that we're going to expect to come back, which is going to be Java versions. And then we also need to tell it the ID type that we expect of that object, which in this case, our Java version ID field is a string. And then we can just close that, and we actually don't need to provide anything here because I'm going to take advantage of Spring's out-of-the-box provided methods. So things like find by ID, find all, so on, are pretty much implemented the same way across the board by most developers. And so what Spring did is they kind of wrote these general implementations, and they're going to let us use those out of the box. And then if we need something custom, we can absolutely write our own implementations and use custom queries and so on to write those. But I'm just going to stick with kind of the provided ones for now. So now we can go on and create our Java version controller class, and this is going to be our REST controller. So we need to tell Spring that this is a REST controller. We need to provide it an endpoint here. There we go. Typing is hard, and we're going to call this /versions. And then we also want Lombok to create a constructor for us with all arguments in this case. And then we can inject our repository, Java version repository. We're just going to call this repo. And then we can start creating our methods here. So I'm going to create one that's just going to do a live check to make sure that the application is actually up and running. So I'm going to create this and just return a string of coffee matrix is alive. Okay, and then we can create another method that's just going to call all Java versions. So it's just going to do a find all basically. So we can have an iterable of Java version, and we're just going to call this a find all, and then return repo.find all. Now notice again, I did not define a find all in that repository. That's because that's one of those used provided out of the box by Spring. Okay, so this is a great start. We have our Java versions defined, we have our interface for the repository, and we have our controller. So we could actually start just like this, and I will zoom this up for everybody. And we'll, go into our demo here, and I'm going to do a maven spring boot :run. And this should run our application. Hopefully everything connects fine. And assuming that looks good, so far so good, I'll open another tab. And I can go to the application endpoint and go to versions, and this should check to make sure our application's up, right? So indeed, we can hit our application. Coffee matrix is alive. So far so good, but we haven't really touched the database at all. So let's do that next. We're gonna go to /all, and this should return our Java versions in the database, hopefully. Yes, okay. So we have our Java version 18 here. We have the dates coming back. Again, there's no code name, but that's expected. But if we go up here, you can see code name does appear on Java version 4 and 5 and 6. And 7 as well. And then 8, it disappears. Okay, so we have all the data returning here, but we really haven't done anything with the graph, right? We haven't done anything with relationships. So let's go back and fix that. We'll dive back into IntelliJ, and we're going to add another class here for version diff. And this is a node in the database as well. And we're going to use our same annotations to let it do the getters, setters, and the required args constructor. Okay, now we need to define our ID. And there really was no good single ID, and so what I ended up doing was just using the internal Neo ID for the node, which isn't always best practice, but that was pretty much all I had at this point. So. Then we also have some other information. So we have from vendor. So when you do diffs between versions, of course, different vendors are going to release those versions. So when they do a diff, they're also specifying not only the version you're working with, but the vendor it's coming from as well. So we have from vendor, from version, to vendor, and to version that it's going to compare. Now that looks good, but again, we haven't wrapped in our relationships. So let's jump back to our Java version, and we're going to tie in a relationship using the @relationship annotation. And I have a couple of different relationship types in my database, but if you kind of remember, we have Java versions, and we're comparing newer Java versions maybe to older Java versions. So I'm going to use this from newer relationship type there. And then I can specify we're going to get a list of version diffs back, and we're going to call this older version diffs. Oops, no, it's not a method. Okay, so we've tied that. We now have a field. We've got it mapped to our other object type here. And that should actually be all we need in order to get this spinning back up. So I'll go back over to my other tab here and rerun the Maven Spring Boot run, and that'll kick off the project. And assuming that all looks good, so far so good. Okay, we're gonna dive over here and now try to pull back all of the Java versions. So now we should get the version diffs. We should be going across that relationship and pulling in those diffs as well. So you can see lots of version diffs when you're dealing with 18, because now you have 17 previous versions to work with. So you have Java version 18, and you can see it's going across that relationship and grabbing the diff. So we have 18 compared to 12. We have 18 compared to 16. You can see the vendors' differences there as well. So all that information is good. We're getting those relationships. But there's a couple more things we could actually be doing here. So first off, I haven't even shown custom queries. So let's talk a little bit about that. I can write custom cipher, and there's a few different queries I could write, for instance, but let's just kind of stick to something general. We'll write the same query that we're getting with the basic find all. We'll just use it, write the custom rendition of that. So we're going to do a match on Java version, and then we're going to grab relationships of from newer, and then we're going to get the diff, and then we're going to return the Java version. We're going to collect the relationships into a list, and we're going to collect the diffs into a list for that. And then I need to write my method here. So we have this, we're going to use an iterable of Java version, and we're going to call this find all custom. Yeah, like that. Okay, so there's our method. We haven't used it up here, and actually I could even define something separate, so we could call separate. So let's just call this custom, and then can't type Java version, and we're going to call this find all custom customer. You have kind of these general things you're used to typing, and they just kind of appear under your fingers. Okay, so now we have this, we're going to call this find all custom, and this all looks pretty good now. So let's switch over to our demo section, and we will restart our application again. Spin this back up. And when that's going, all good. Okay, let's try this. Now we know we already have the all in place. Let's do the custom. So this is our custom query. We shouldn't see any difference in the results, really. We're just now using a custom query versus Spring's internal one. So you can see we still have our Java version 18 coming back, and we've got the version diffs in there as well, a full list of them, 12 versus 18 and 16 versus 18 and so on. Okay, so this is looking good, but there's actually one step further we want to cover here. And that is, that's a lot of data coming back, right? Maybe we don't need all of that. Maybe we just want to look at the versions themselves and kind of slice that down a little bit. Something neater, cleaner, maybe show a full list that people can click on and dive into, right? And so to do this, we can write a projection of the entity itself. So here we're going to create a new interface, and we're going to call this Java version projection. And within that, what we're going to do is we're going to call the getters for the fields within the domain objects that we want to retrieve. So for instance, we want to get the version, so that we're just going to call get Java version, like that. And then we want to grab the older versions that it's pulling the diffs for, right? And so to do this, we're actually going to create a nested projection, which is kind of neat. But we have a list of, we're going to call it diff projection, and we're going to say get older version diffs, like that. And then we can create a nested interface here called Diff projection. And get the string get from version. So here what we're doing is we're starting with, we have a Java version. We only want to get the Java version field off of that domain object. But then we want to traverse across the relationship and get the connected object of diff, the version diff, and we want to grab the from version field off of that object and pull that back as well. And so that's why we have to have this nested projection. We've got that Java version at the high end, and then we're going to grab the nested field that's going to go across the relationship and grab the other field on the other side. So now what we need to do is specify that we want a Java version projection to return, because obviously this is grayed out, it's not being used anywhere. So here we can specify we have a Java version projection that we want to retrieve. Of course, that's going to give me an error up here because I have it wanting to return a Java version. So I need to have it return the projection there as well. So let's slide back over then to our terminal. We will spin up, or spin down and then spin up our project one more time and see how the projection changes the data that we're getting back. Okay, that looks good. And we're going to stick with that custom rendition. And we get this nice slice now. So we have Java version 18, and now we have all the diffs that are compared to 12 and 16 and 2 and 3 and so on. So this nice, neat, clean, concise format. And we could even go back and look at, go back to that all, which is going to retrieve everything all over again, all the relationships, the full objects, so on. And you can see that's still there. It's just that we're creating basically a view of our object to kind of pick and choose which fields we want out of that. Okay, so let's jump back to our slides then, and we will kind of wrap up with some resources. So we have the source code at the top. Everything I built today is in that first link. There's also a little bit more complex version that's linked out there in that GitHub repo too. So the full domain model where we have the methods and fields and all that deltas between the versions, that's built into an application that's linked from there as well. If you're interested more in what Spring Data and Neo4j provides, what's there and featured, you can find that in the documentation there on the second link. There's a ton of cool other features that I didn't even touch on today. Neo4j Aura DB, that's the link for that. Again, everyone can access a free instance. You just need to fill out the form and spin up a free instance there. And then I have a blog that I write a lot of content based around Java, Neo4j, and so on. My latest kind of rendition this year is diving into microservices. And I built a lot of kind of fun things with that. But that's all available on my blog. So if you're interested in Java and graph stuff, feel free to check that out. Again, my contact information is there on the lower left-hand side. I'm more than happy to answer questions. And again, I'll be around the rest of the conference as well. Thank you guys so much for coming, and hope you enjoy the rest of the conference.